Okay, 7.2, we talked about the third method of solving a systems of equation, which is elimination. Okay, in the first one, it says to solve using elimination, remember to pay attention to the directions. If it tells you something specific, you want to follow that process. If it just says solve, now you've got 3 choices. Okay, so this one we're practicing elimination. What's one way to do number 1? Because again, there's always more than one way. Okay, top by 3, bottom by 2. What's another way?
Multiplying the bottom by 3.
Bottom by -3, right? Yeah. Okay, so I'm just going to do the first way, but you could have done it either of those ways. So negative 9x plus 6y would equal negative 21, and then 2x plus 6y would equal 12. This is negative 7x. Oh, wait, I didn't need to do negative. Hang on. It was already negative. So that should be a positive 3. 9x minus 6y equals 21. And then 2x plus 6y equals 12. I get 11x. These cancel. Equals 33. X equals 3. Take it, plug it back in anywhere you want. So if I plug it back in here, 3 plus 3y equals 6. 3y would equal 3, and y equals 1. 3, 1 is the solution. Again, no matter how you did that, you should have gotten the same solution. And with extra time, you can take them and check it. Okay, 2 has a decimal in the first one, so if you wanted to get rid of it, you could multiply by what? 10 in the top. And I'd get 18x plus 12y. Don't forget to go across the equal sign to the 4. Now I could do what? I could do top, yeah, the original bottom, by a -2, so I get negative 18x minus 12y equals negative 6. These are going to cancel. These are going to cancel. I get 0 equals 34. Is that a true statement? So it's no solution. And 3, you've got your fractions. If I wanted to get rid of the fractions in the top, I could multiply by what? 8 here. 4 goes in there twice, so 2 times 3 is 6x plus 8y would equal 1. Multiply the bottom by 8 as well. And 4 goes in 8 twice. That's 18x plus 24y equals 3. Now I can multiply the top by -3, negative 18x minus 24y equals -3. And this time, left side equals right side. So this is all real numbers. Questions so far? All right, 4 says a grocer sells oranges for 95 cents each, God bless you, and grapefruits for $1.05 each. You purchase a mix of 16 oranges and grapefruits and pay $15.90. How many of each type of fruit did you buy? So let's say our oranges are our X and our grapefruits are the Y. What's true about the total X plus Y that I purchased? 16 of them. Then I want to give them their value, right? So oranges, God bless you, 0.5x plus grapefruits 1.05. Y equals $15.90. So I can multiply this entire thing by 100 this time. And then I have choices. You can either use substitution by solving the bottom for one of them, or you can use elimination. Let's practice elimination so I can multiply by like -95 here. God bless you. And then add it to that top one. These are going to cancel. This is a positive 10 and 70, and y is 7. And then if there are 7 grapefruits, 16 total, that means there's 9 oranges. So remember, you'll get to use a scientific calculator on Thursday's quiz. Obviously, for stuff like that, it's going to be helpful. You can do that without one. So if you show up with a graphing one and you're stuck without, you can survive. It just won't be pleasant. So if you haven't been bringing your scientific one, maybe set an alarm for yourself to make sure you have it with you. on Thursday and you're practicing these questions with that.
On the homework, are we gonna need to know that the
Really see heads. I'm not going to tell you yes or no. You're going to see this question, but headwind and tailwind is something that can definitely come up in word problems. So this one says an airplane flying into a headwind travels 1,800-mile flying distance between New York and Albuquerque in 3 hours and 36 minutes. On the return flight, the same distance is traveled 3 hours and 20 minutes. Find the airspeed of the plane and the speed of the wind, assuming that both remain constant. So the first thing you have to kind of like pay attention to is that it's talking about miles per hour. So I have to take that 3 hours and 36 minutes and 3 hours and 20 minutes in this case and convert it to hours. And the other thing is you have something called headwind and tailwind. So headwind comes against the plane and slows it down. Tailwind comes behind the plane and speeds it up. So when I have something like, if this is, distance equals rate times time, the distance is the same for both, right? It's 1,800. The rate, if I have tailwind, is slowing it down. So it's the rate minus the wind. The headwind is slowing it down. The rate, when it's got tailwind, which is coming back the other way, would be R plus W, which makes sense that it covers that distance in less time because it's speeding it up. So then the time is what I have to figure out. So 3 hours and 36, would be 3 1/6. If you did it in decimal form, this one actually terminates. 1/6 is that terminates, but 1/3 does not. So you needed to keep it exact, which would mean a fraction. So this could be 19/6. And then the other one is 3 hours and 20 minutes. So 3 hours and 1/3, or 10/3. That's your rate. Yep.
Wait, for the 3 hours and 36 minutes, would it be 3 hours and 6/10?
Oh, 6/10, which becomes 0.6, right? Or 3 3/5. So that one you could have done. So wait, this is. Yeah, but I would keep them in terms of the same thing. It's fine. Okay, so I'm going to change this. It's still the same thing, right? Okay, so the easiest thing to do here is actually get rid of this time by multiplying by the reciprocal on the other side of your equal sign. And then you can set it up for systems. If you didn't catch that, then you have to distribute it in and you've got to multiply each line by the other side. So if I did 1,800 times 5/18, I get R minus W equals 500. And then if I did 1,800 times 3 divided by 10, I get R plus W equals 540. Now I've got an easy system. 500 equals R minus W, and 540 equals R plus W.
What did you multiply the second equation with?
I got the whatever the fraction was, so the time, I got rid of it.
Okay.
Because you could distribute it in, but then you have to change both equations. Yeah, it makes it a lot harder. So because it went in evenly, I would have done it that way. It makes it a little bit easier. So then if I add these, right, I get 1040 equals 2R. These are going to cancel. And then 1040 divided by 2 is 520. So on this example, the rate is 520. And then I could pick either of these. 500 equals 520 minus W. Negative 20 would equal negative W, and W equals 20. So I'm not going to say you're never going to see headwind and tailwind again, okay? Remember that a tailwind, and it should make sense because it will travel in a faster time. Tailwind is adding to the rate. It makes it faster, and headwind coming against the plane makes it slower. Okay, so today is 3 variables, 3 equations, okay? 7, 3, and also partial fractions. So 3 variables, 3 equations you have done before, okay? Hopefully that part's a review. Partial fractions is going to be completely new to you. And we're going to divide this into 2 parts, today's partial fraction and tomorrow. The stuff that we cover up to today is what will be on your quiz on Thursday. The stuff that we cover tomorrow, I won't put on the quiz, but it will be on your test. Okay, so it's something called a repeated factor. Quiz is Thursday. And then test is next Thursday. All right, so first of all, just the way we do everything else, if I give you a solution and it's a point and it's the solution to the problem, that means that you can plug it into all three equations here, and the left side should equal the right. So I'm going to take this as my x, this is my y, this is my z now, because there's three variables. And I'm going to plug it into all three of those equations to show that it's, to see if it's a ordered pair or show that it's an ordered pair. So I get 1 minus 3 times 0 plus 2 equals 3. 1 minus 0 plus 2 equals 3, and 3 equals 3.
What are we doing, matrices?
7, 4. Then 2 times 1 plus 0 minus 5 times 2 equals negative 8. 2, this is gone, minus 10, negative 8 equals negative 8. And the last one, 1 minus 0 plus 3 times 2 equals 7. This is gone. 1 plus 6 equals 7, and 7 equals 7. So again, you're not going to get like a test question or a quiz question that says show that it is, but the point of this is to say, if I know my answer, then I can take it and plug it back in and check it. So every systems of equation can be checked.
Yeah. When you don't have the solution, don't you just make a matrix?
No, we're not going to do matrices in 7-4, so I'm going to teach you elimination with this.
Because I did a matrix.
Okay, so 7-4 is matrices.
Oh, yeah.
Yeah, today I'm going to show you a different method. And you're going to eventually learn 3 ways to solve a system of 3 equations. You need to know how to do them all. Okay. All right, so the first is super easy. This is called a triangle system because if you look at the shape of your question, it's in a triangle. And it's basically telling you that one of the lines is going to give you a solved variable. It's only got one variable. One has 2 variables and one has 3. So this is, we call this back substitution, when we're taking the number at the bottom and plugging it into the second one. So this would be 2y minus 3 equals 7. 2y would equal 10, and y would equal 5. And then we've got 2, the one that's on the bottom, the one we just found, and it's 3x plus 5 plus 2 times z, which is 3, equals 8. Oh, 3x plus 11 equals 8. 3x equals negative 3, and x equals negative 1. So the solution here is negative 1, 5, 3. So a triangle system has one already solved, or to the point that it can be solved. Maybe it was like 3z equals 9, something like that, and you can solve it. It only has one variable. Then one that has 2 variables, then one that has 3 variables. So you just work your way bottom up to solve these. Should have gotten negative 13, negative 10, and 8. Everybody good on that? So you won't get a question outright that says that has a triangle system, but you need to know how to do this in order to get to the next part. And when we do matrices, same thing. You need to know how to do those triangle systems. All right, so 3 equations with 3 variables. It's a lot of words, so hopefully once you start to practice it, you don't need the words anymore. But if you get stuck, this is like where you can come back to. You're going to get 3 equations, 3 variables. You're going to pick any 2 of the 3 equations to cancel out any one of the 3 variables. That first one is your choice. Pick anything you want, any of 2 of the 3, and then get rid of any of the variables. We're going to call that new equation new 1. Okay, so what we get from combining 2 of them. Then you have to use the third equation that you didn't use originally with either of the 2 you already used. But you have to cancel out the same variables. So if I canceled x from the first one, I have to cancel x from the next set. If I canceled y, I have to cancel y. If I canceled z, I have to cancel z. Now I've made 2 new equations, and it's a system of 2 variables, 2 equations. You probably will do elimination, but you could do elimination or substitution after that. Get it down to one variable, plug that into one of the new equations. This is your back substitution part. Get the second variable, take those two variables, plug them into one of the original equations, and you'll get all three variables. All right, so we're gonna look at these three, and we're gonna try to plan ahead and see if there's something that would easily be canceled out more than once. Again, there's not always one way to do these. So I'm gonna number them so that we can refer to them by number. I wanna pick any two, and I wanna cancel out any variable from them. So what's something you could do?
Multiply the middle by -2.
And multiply, and add it to what?
Top one.
Okay, so we're saying take 2 and 1 and multiply the second one by -2. That would work, right? Okay, so let's do that. 1 is going to get left alone. 2x plus y plus 3z would equal 9. The second one, I'm going to multiply by -2. So -2 here would be -2x plus 4y minus 2z equals -16. So that's -2 times 2. Now my x's are going to cancel. 5y plus z equals -7. And this we're going to call new 1. Now I have to use the third equation because I haven't used it yet. But I can use either of the other two, but I also have to cancel out the same variable. So which is the easiest to do? And it doesn't really matter. You're doing the same step either way, right? Take 1 or take 2. You pick. Take 1, multiply 1 by what? So I'm going to multiply 1 by 2, and I get 4x plus 2y plus 6z equals 18. You could have also taken row 2 and multiplied it times +4, and it still would also cancel out. This is gone. 5y plus 8z equals 14, and this is new 2. With me so far? Now we have to use new 1 and new 2. And I have to cancel out one more variable. What's easy to do?
Multiply second one by
Okay, second one by -1. So I get -5y minus 8z equals -14. And I bring down the first one, 5y plus z equals -7. This cancels. -7z equals -21. Z equals 3. There's the first variable. Now this is where the back substitution comes into play. I have to take that and I have to plug it into one of the new ones, and it doesn't matter which one. So I'm just going to grab that first one. Now I've got my second variable, and these have to be plugged into one of the original ones. Again, it doesn't matter which one. There's less multiplying on number 2, so I'm going to take that one. And there's my third variable. And then again, these will be written as coordinate points. 1, -2, 3, and with extra time, you can work your way back in by plugging those in to make sure they work. Questions? Then did you use 3 and 1?
Yeah.
It's just new 2 meaning like there's a second equation. It has nothing to do with the numbers that you use. So now this is -3. Whatever you choose in the beginning, whatever variable you've eliminated, you have to pick the third equation that you didn't use the first time. And you have to cancel out the same variable. But which one you cancel it out with is completely up to you. So if I had done 1 and 2, I have to use 3, but I could use 3 with 1 or 3 with 2. It's just that you have to cancel out the same variable. So in this case, it's probably easier, instead of having to do, if you pick 2 and 3, you got to multiply both, right? You got to multiply 2 by -3 and 3 by 2. So it's easier to use the ones that don't have a number on the front. It's not the only way to do it. Okay, so now I've got, this case was new 1 and new 2. If you don't have the same variables at this point, because that's a common mistake people have, you canceled out something wrong. You have to go back and cancel out the same variable. This one, I still have to do one more step. I'd have to multiply this by 3. So I get 6y minus 39z equals, thank you, -81, and then -6y minus 5z equals -7. Cancels, -44z equals -88. Z equals 2. There's the first one. Take it, plug it back into either of the new ones. So let's say I plug it back into here. -6y minus 5 times 2. And I get -1/2. Take them, plug them back into the original ones, excuse me, and I can pick any of them. So I'm certainly going to pick one that has like an even number against the y if I can, to cancel out that fraction, which would be that second one. So 2x minus 4y plus z equals 7. 2x minus 4 times -1/2 plus 2 equals 7. So I get 3/2, -1/2, and 2. So I'm not going to tell you you'll never see a fraction. You'll probably never see something like 832/17. Okay, so some people get those kind of answers. That's probably not happening. But you can see a fraction here or there. Yep. Two things. The two special cases on this come also no solution and all real numbers. So if you end up with a statement like 0 equals 3 anywhere along the way, it's no solution. If you end up with a statement like 0 equals 0 when you combine 1 and 2, then you also have to use 3 with either 1 or 3 with 2. And if you also get a true statement, then it's all real numbers. So you only need one false statement to say no solution, but you need 2 true statements to say it's all real numbers. And then I think it happens in the homework, like let's say you have something x, y, z equals a number, x, y, z. I'm not saying this is the same thing, but then you only have y and z. This is already like your new 1, so it saves you a step. Then you have to take the other 2 and cancel out the same variable. So if you get lucky and you have just 2 variables, it already gave you like a new 1. You have to use the other 2 equations to cancel out the same variable to get the new 2. All right, so we're going to talk about partial fraction decomposition. This is something that you've never seen before, okay? It's not that it's foreign to you, so it will feel like it's rough, but the actual process is not that bad. The idea is that when we take, let's say we're used to doing something like the stuff on the right-hand side. We're used to taking 2 fractions that have a different denominator, finding a least common denominator, multiplying the numerators by that least common denominator to combine them into 1, right? So we're used to going this way. Now we're doing the breakdown. We're actually decomposing these, so we're working in the other direction. So you're taking something like this, and you're turning it into something like that. The good thing, again, is these can always be checked. I can always go back right to left, and you should get your question with extra time, okay? But I'm going to walk you through the process, but this is called partial fraction decomposition. We're going to do some today and then the harder part tomorrow. That stuff will wait for your test. It won't be on your quiz. So what we do up until today is what will be on your quiz. This is just a basically dragged out form of what you have to do. The process is going to be to, if it's not already, factor the denominator, separate it out for one term for each fraction like is done here. So that they basically took something that was already factored and split it up into its factors. And then we give each numerator a constant. So we call these A, B, C. If there was 4 terms, it'd be D, and you would go so on and so forth. And then eventually we are going to fill in those A, B, C's, but we're going to baby step our way into that. So the first step, factor your denominator. Second step, split the fractions for each term in the denominator. Third step, give the numerator A, B, and C for each fraction that you've got. Okay, again, this is the first set of steps. Those questions will look like this. This just says write the form of the partial fraction decomposition of the rational expression. Don't solve for the constants yet. We'll get there, but not yet. So looking at A, I want to first focus on just the denominator, right? X squared minus 4x. How do I factor that?
X plus 2x minus 2.
Nope,
Oh, wait.
because there's an x on there.
Take out an x.
Yeah, take out an x. So x times x minus 4, right? There's 2 terms there. This is one term, that's the other term. So I say A over x plus B over x minus 4. And then that's all we're at right now. For each term that's there, you're going to split it. If it's already factored, you just split it up. Split it up. If it's not factored, you're going to factor it and then split it up. Now I go to B. Can I factor the denominator in B? No. It's already split up as much as it can be, but there are still 2 factors there. So this would be A over x plus B over x squared plus 3. Good so far. Okay. Now 1, 2, and 3 are the same. 4, 5, and 6 is what we're adding. Factor the denominator. Split the fractions for each of the denominators. Give a numerator of A, B, and C for each fraction. Then we're going to take just the initial expression and we're going to set it equal to A times whatever is missing from the denominator of A plus B times whatever is missing from the denominator of B plus C, and so on and so forth. We're going to find a value of x that would make each term cancel out one at a time and plug that value in, and then we're going to repeat it for all the constants. So if I have an A and a B, I'm doing it twice. If I have an A and a B, a C, I'm doing it 3 times. Okay? So let's work it through. So this one's already factored, yes? So we're going to notice the directions change. This actually says find the partial fraction decomposition, so it doesn't say not to solve for it. So I write it first as A over x minus 3 plus B over x plus 5. Now, the long way to do this is if I wanted to combine and to get a least common denominator, I would have to look at x minus 3, compare it to the side on the left, and say what's missing from that denominator to the first one. X plus 5. And if I was walking through the motions, I'd multiply this times x plus 5 and this times x plus 5. I'd get A over x minus 3 times x plus 5. A times x plus 5 over A minus 3 times x minus 3 times x plus 5. Then I go to the second denominator, what's missing from here to there. X minus 3, so I would multiply times x minus 3 in both the top and the bottom. And I would get to this step. So the good news is from there on out, the denominator is all the same, which is why I can actually ignore this step and just look at my numerators. So you need the bottom to know what's missing, but you actually don't have to multiply it by both the top and the bottom. We're going to skip that step. And we're going to say if all the denominators are true, then all the numerators would be equal. So we are once we figure out what's missing, we are completely ignoring the denominator until the very end. Now, one at a time, I want to cancel out these variables. So you can either take and solve your factors to figure it out, or I can simply look and say, what would cancel out this parentheses to give that a 0? -5. So I'm going to first plug in -5. Then what's going to cancel out this parentheses, giving that parentheses a 0? positive 3. So I'm going to do it twice because there's 2 of them. 6, and I plug it into every x that's there. So 6 times negative 5 plus 14 equals a times negative 5 plus 5 plus b times negative 5 minus 3. Negative 30 plus 14 equals, this is 0, and that's gone, which was the point of it. B times negative 8. Negative 16 equals b times negative 8. Divide both sides by negative 8. And b is 2. Then I'm going to repeat that process for the one on the right, plugging in a 3 in here, and here, and here. 6 times 3 plus 4 equals a, 3 plus 5, plus b, 3 minus 3. 18 plus 14 equals a times 8. This is 0, cancels out the b, which was the point. 32 equals a times 8, and a is 4. Then the very last thing I'm going to do is take that a and b and plug it back in to these fractions. So 4 goes over x minus 3, and 2 goes over x plus 5. This, combined together, would give me that. All right, denominators again already factored, yes? So the first step is this is a over x minus 2 plus b over x minus 5. What's missing from the first fraction? X minus 5. What's missing from the second fraction? X minus 2. So now I'm going to ignore all my denominators and say x minus 14 equals a times x minus 5 plus b times x minus 2. Now again, you can just say, okay, what's going to cancel them out one at a time? Or you could come back to your denominators, set them equal to 0, and I get 2, and I get 5. So I know I'm going to make x equal 2, and then I make x equal 5. So 2 minus 14 equals a times 2 minus 5 plus b, 2 minus 2, negative 12 equals a times negative 3. This is 0, cancels out like I wanted it to. A is 4. Repeat the process for 5. 5 minus 14 equals a times 5 minus 5 plus b times 5 minus 2, negative 9. This is now 0, cancels out. B times 3, and b is negative 3. So at the end, I get 4 over x minus 2 plus negative 3 over x minus 5. Now we don't normally see a negative on a numerator, so we're going to take that out and put it between them. Andy?
What is the x for the 85?
The x for to cancel out the a is 5. Right? This cancels out the a, which will answer b. This cancels out the b, which will leave an answer for a. So what you're plugging in to cancel out leaves the other variable. Does that make sense? As long as you do both, you will eventually get both. It doesn't matter what order you do them in. Now we're going to factor, right? So x to the third minus 4x. What can I do with that? Take out an x. And then I get x squared minus 4. Am I done factoring? No, I have to do x. X plus 2, x minus 2, which means a over x, b over x plus 2, and c over x minus 2. So now I'm plugging in 3 values for x. What's going to cancel out the first one? Like if I set this equal to 0, right? I get 0. Set this equal to 0, I get negative 2. Set this equal to 0, I get positive 2. So this A gets both the x plus 2 and the x minus 2 because it's missing both. The B gets the x and the x minus 2, and the C gets the x and the x plus 2. So I'd get x squared plus 12x plus 12 equals A times x minus 2 times x plus 2 plus B times x minus 2 plus C times x plus 2. And one at a time, I plug those in. If I plug in a 0 into the B, because it's times x, the B's gone. I plug a 0 into the C, because that's x, that's gone too. Which means I get 0, 0, 12 equals A times negative 2 times positive 2. Then I plug in negative 2. The negative 2 is going to cancel out the A and cancel out the C, which means all that's left is B. And then 2. If I plug in 2 in the A, it's gone. I plug in 2 in the B, it's gone, which means there's only C. So A is negative 3 over x, plus B is negative 1 over x plus 2, plus C is 5 over x minus 2. And that minus is going to go in between